Okay. If you come to class without your pre-lab done, what consequences are there? If I didn't say it, what would you think would be the consequences be? Yes?
You would get points off or may not be able to participate in the lab.
Good. Points off, may not be able to participate in the lab. All right. Usually I take 30 points off. Boom. If you don't do your pre-lab. If you come to class on a lab day with open-toed shoes, what will happen? Yes?
You either put those thingies on.
Those thingies, which are called hospital booties. Or
you put tin foil.
aluminum foil. Or if it consistently happens, then you're just not going to get in the lab, and I'll just give you some data. And if your beaker is dirty, when you get into the lab, what should you do?
Change it or clean it.
Change it or clean it. Let me know. Okay? Any questions before we begin on the next part? Okay. All right, today we're going to talk about accuracy versus precision. So the definition of accuracy is, it is the closeness of measurements to the correct or accepted value. All right, so let's play a guessing game. Let's guess my age. There we go. 46.
23.
23. He's going for A here. 40. Any other guesses?
38.
38. 35.
43.
Oh, wait, hold on. Let's go back. Hold on. Let's write these down. Somebody said 40. What did we say? 46? Oops. 46. We had 40. We had 43. Somebody said 38. Oh, Micah back there is going for extra points with a 23.
Oh, you look.
I say 21. I say 21.
21. Oh, she's like up in the game here.
Don't look a day over 12.
Okay, so my actual age, next month, I will be
35. What?
So 43. Who said 43? 43. She's the one that is accurate because she guessed the closeness to my age. So she's accurate. Okay? Now, precision is the closeness of the set of the measurements to each other. So if we were looking at this, would we have been precise? No. Okay, so precision is the spread. How wide is your spread? Is your spread like this? Then you're not precise. But if you are shooting and your spread is really close together, then you would be called precise. Okay? Are there any questions over the definition between accuracy and precision? Okay. Let's draw these out. Here we have 4 targets. And we have the Y listed as accuracy. And you can be low, and we have high accuracy. And then we have precision, and we have high and low precision. So on each one target, we're going to draw, I like X's, so I'm going to draw X's on the appropriate level of accuracy and precision. So high accuracy, high precision. Where would I draw my marks? In the middle circle. So we would have like that. Okay, so that is high accuracy, high precision. What about low accuracy but high precision? Where would I?
On the very edge, but all grouped together.
On the very edge but all grouped together. Okay. What about low precision, low accuracy?
Around on the edge.
Okay, so if you have a high accuracy but low precision, what do you think that's going to look like?
So like 2 in the middle, 2 on the outside ring,
Okay, yeah.
or like not the very outside, but in the middle.
So we could have one here, and then like that. Okay? So you must be able to look at those if I give you a picture and decide if it's accurate, precise, both, or neither. Any questions? The next thing I want you to be able to do is I want you to be able to look at numbers and identify them as either being accurate, precise, both, or neither. So this measurement, so you're in groups of, we have 4 groups, and each group went in there and they took some measurements of something. The actual measurement was 68.1, and this is the data that each group came up with. We have A, B, C, and D. So what I want you to do is I want to give you a few minutes to look at that data and then to label each one as either being accurate, precise, both, or neither. Okay, so I'm going to give you a few minutes. All right, A. How are we classifying A? Neither. And why do we say neither? All right. Doy says random is all get out. B. What is B? Both. C is precise. And D. It's accurate because of that one measurement, but it is not precise.
So it's low accuracy.
So low accuracy, yes. Any questions on that? All right. We're going to talk about measurement. So we like to work in the metric system here. So volume. What do you think volume will be measured in this class? Liters. We might make that into milliliters or kiloliters, but it is always going to be liters. And that is a big L. Mass? Grams.
Kilos.
I will require you to go from milligrams to grams to kilograms. Do those little conversions. Length. Meters. And temperature. Celsius. So degrees Celsius. Or we're going to use something here. It's called Kelvin. So Kelvin. And we'll use that next semester. But we do not use Fahrenheit. I won't require you to convert from degrees Fahrenheit to degrees Celsius. But we will convert back and forth from Celsius to Kelvin. And that is pretty easy, yes. All right. So scientific notation. Scientific notation is where we will take a number, a very, very, very large number, or a very, 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 very small number, and we will take it and put it into something that's easier for us to work with. And this should say 1. So what happens is we are going to place a decimal somewhere. And we're going to move that decimal. Every number has a decimal. It may not be written, but we're going to take that decimal and we're going to move it either to the left or to the right. And then what we're going to do is we're going to represent that movement with 10 to the n, where n represents whether we moved it to the left or to the right and how many places we moved it. Okay, so there's a very large number that we use in here, and it is called Avogadro's number, and this is it. It is 602, 2, 3, 4, 5, 6, 7, 8, 17, 18, 19, 20, 21, 22, 23. Yes, it is on the poster right over there. That is the number. Every time I have to use that number, I do not want to put all those zeros in. It is 21. No, 22. That one. So what happens is I know that there's a decimal at the very end. And I'm going to move that decimal so that I can work with this number. So what ends up happening is I move this decimal all the way over to here, and my number ends up being 6.02 times 10 to the, how many places I moved it? 23.
Wait, why is it 23 there?
There's 21 zeros after the 2.
So then,
That is very ugly. Hold on, let me go back.
oh, because you move it from the end of the number to the first number?
To the very first number. I only want one number in front of my decimal, okay? When we move our decimals, we only want one number in front of our decimal. So if I have an imaginary decimal here, right here, and I want one number that's greater than 1 but less than 10 in front of it, where am I going to move it? Where am I going to move this decimal to?
The 1.
Between the 1 and the 5, right? So we move it. 1, 2, 3, 4, 5, 6. 1.5 times 10 to the however many places we moved it. It's a number greater than 1, so it's going to be a positive 6. This number is less than 1. I want to take this decimal that's here and I want to move it to there so that it has one number in front of it that's greater than 1. And that would be where? Behind the 2. So we moved it 1, 2, 3, 4 places. And we moved it this way, so it's a negative 4. So 2.5 times 10 to the minus 4. Okay? You're going to have math problems in here, and you're going to write your answer, and your answer might come out to be, in the calculator might say 2.01 times 10 to the negative or to the positive 2. My answer key might say 201. Both answers are correct. One's just in scientific notation and one's not. So I'm going to take either answer. If you like working in scientific notation, then that's fine. I'm not going to count you off for it. Okay? So let's do some practice. All right, let's work the first one together. 3,400. Where's my decimal going to go? Behind the 3. So 3.4 times 10. And how many places did I move it?
3.
3. Positive or negative?
Positive.
So we were right here, and we moved it 1, 2, 3. So I want you to take a few minutes and do 2, 3, 4, and 5. Number 2. Where's the decimal going? 2.3 times 10 to the, how many places did we move it? Negative 5. Number 3, where's the decimal go?
After the first one.
After the first one, 1.01 times 10 to the how many? 5. Number 4. After the 1, 1.0 times 10 to the negative 2. And number 5. Where's the decimal go? 4.5 to the 4th. Good. Any questions over that? All right, let's go back the other way. 2.30 times 10 to the 4th. So I have 10 to the 4th. So where am I placing my zeros, in front or in back?
Go back.
They go back, in the back. And how many zeros am I adding at the back?
You're adding 4 places.
Adding 4 places. So 2, 3, 0, and add 2 zeros. 2,300. 23,000. My. All right, I'm going to give you a few minutes to work on that, and then we are going to talk about significant figures. Number 2, where's my zeros going? To the front or the back? And how many zeros am I adding? 0.00176. Number 3, zeros go to front or back? Front. How many zeros am I adding in the front? 6. So 0.12345 1901. Number 4, am I going to the left or right? I'm going to the back. And how many zeros are we adding? 1. So 9110. And number 5, what's my number going to be? 54.0. Do we have to put the point 0? I'm going to say yes. And you're going to find out here in a minute. Okay? On number 4, didn't need a point 0. The 0 was already there in the number 5. If that would have been 9.110 times 10 to the 3rd, I would have written 9110 point 0. That needs another. Wait, hold on. 1, 2, 3, like that. 1, 2, 3. Point 0, right there. Yeah. Okay. That does not. Let me go back. That looks dirty. 0 times 10 to the 3rd. I would have done 9110.0. Okay. All right, and we're going to explain that here in a minute. So what we're going to talk about now are significant figures. In science, numbers matter because we are working with measurements. And when we work with measurements, we always, or any measurement equipment like that's back there, we always go one past what we can read. So if you're reading a ruler, okay, and the ruler is, you have centimeters. So you have, say, 1 centimeter here, and you have 2 centimeters here, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks in there. And you measure a string, and the string goes to right here, falls in between these 2 tick marks. We're going to guesstimate what that is. We always do that here in science. We always go one more than what our thing can measure. Okay, so this would be 1.123, and then 5. All right, and it's kind of subjective. It's how you're reading it. All right.
How big your eyes are.
Yeah, that's true. All right. So there are types of numbers that we count. So Any non-zero number is significant to us. So say if we have the number 1, 2, 4, 6. Those are all non-zero numbers. And how many of them do we have? There are 4. So I would say that there are 4 sig figs. All 4 of those numbers are significant to me. Now, we have zeros, and there are several types of zeros. So if you have a zero that is at the very front, we call it leading, those are never going to be significant. So if you have the number 0.001246, those zeros are at the front, and they do not matter to me. They are insignificant. So how many sig figs would this number have?
4.
4. If our zeros are trapped, they are always going to be significant. So if I have the number 101, my zero is trapped. It can't go anywhere. So how many sig figs would there be? There would be 3. If I have the number 100 with a decimal there, that decimal traps those zeros. And you will see that a lot of the times in the papers that I give you, I'll give you a number, and the number will be, say, 100. The measurement's 100, and there'll be a decimal there. And that decimal is there for a purpose, because it traps those zeros. And it's saying that those are significant. So this one would have how many significant figures? 3. Whereas if it was just 100, it would only have 1. And I'm not going to just make you test you off the bat. You're going to be tested over this throughout the year. This is something that I'm going to make you're going to use throughout the year. When you go to physics, you're going to use it throughout physics. Trailing zeros, zeros that are behind. If they are behind a decimal, they count. So 1, 0.00. This zero is trapped because it's between here, and so that one counts. These zeros are trailing, but they are after a decimal, so they count. So this has 4 significant figures. If there is no decimal, then they don't count. So this one would have only how many sig figs? 1. Okay? And I can,
Why are the ones behind the zero equivalent matter?
why do they matter? They matter because it's telling me how precise my equipment was.
Okay, but if I have the number 1,000, why do those 3 zeros, even though they're placeholders and recognize the number as 1,000 instead of 1, why do those don't matter?
Because they're just placeholders.
Okay.
All right? They're just placeholders. They're not telling me how precise my equipment is. Yes?
But don't these still have a value even if they're placeholders? Because there's a representation of the 100s?
Okay, so let's think about it this way. If we have the number 1,000, how else can I write that? 1 times 10 to the 3rd. Okay? So this is just placeholders. Those wouldn't count when we're talking about sig figs because they're just zeros. So let's do some practice real quick. All right, so I always look at my numbers. 2.03. I go in and I count the ones that are non-zeros. So we have 1, 2 is a non-zero, and 3 is a non-zero. So I know I at least have 2 sig figs. Now let's look at the 0. Is the 0 trapped? Yes. So how many sig figs do we have? 3. go to number 2. The number 1 counts. So I have 1 sig fig. Now the 0, is it trapped? No, it's not trapped. Is it leading? No. Is it behind a decimal? Yes. So does it count? Yes. So we have how many sig figs? 2. Oh, yeah. I saw you. Number 3, the 2 counts, and our zeros are behind a decimal. So each one of those counts. So how many sig figs do we have? 3.
Wait, what? Oh. Okay.
You good?
Yeah.
Okay. And number 4. The 8 counts. The 6 counts. These zeros at the front are leading. So do they count? No. And what about the 0 at the end? Is it trapped? No. Is it? It's not leading. It's trailing, right? Is it trailing after a decimal? It's after a decimal because we have this decimal right up here. So that's after a decimal. So it's 3.
Oh.
Okay. So while these are after a decimal, but they're leading. But this one is trailing, and it's after a decimal. So it would be 3. I'm going to do number 5 with you, and then I'm going to let you guys work the rest. Number 5, how many are there? 5. 1 counts, 3 counts, 0. These 2 zeros are trapped. And this 0 is after a decimal, so it counts. So there would be a total of 5. Are there any questions over that? Now, this stuff we went over today will not be on your quiz tomorrow. Quiz tomorrow is just lab safety, lab equipment, safety symbols, and SDS. Questions?